This video goes through the solutions to the recent probability test worksheet. Question 1A part 1 gives you a problem where you've got 5 students doing a puzzle and the chances of each of them solving it are given by these values. You're told the probability of all 5 students solving the puzzle is 3 over 160. Find the value of A. So this 3 over 160 is the probability of this person and this person and this person and this person and this last person all solving it. Of course, the word "and" means we want to use multiplication. So I'll multiply all the values and that gives me the result of 3 over 160. I can tidy this up to get 1 over 32 by A equals 3 over 160 and then just bring the 1 over 32 across and divide. This gives a final solution of 3 over 5 for A. Next we have part 2, find the chances that at least one of the students solves the puzzle. I've just written our original probabilities down here one more time so we can see them clearly. Watch out for this kind of wording, at least one. This means 1 or 2 or 3 or more of the students solve the puzzle, and there's quite a lot of work in doing the question in that way, but actually we can take a much simpler approach for ourselves if we think of at least 1 as being not 0. So that's the only option that wouldn't work for us. Remember that not means that we calculate using 1 minus the probability of the event. So in this case, it's 1 minus the probability that nobody solves the puzzle. Up here we have all the probabilities that they do solve it, and of course we have the A found from the last time. So we can just take each of those from 1 to work out the chance that they don't solve. So now the chances that nobody solves the puzzle are each of these numbers multiplied together. This gives 1 minus 1 over 32. So the probability that at least one of the students solves the puzzle is 31 over 32. Moving on to question 2. So we've got quite a wordy question here, a random sample of 160 people, 55% male, 45% female. We've got figures then about the percentages of people reading the newspaper weekly. And then we're asked if somebody's chosen at random, what are the chances that the person is female given that they read the local newspaper? Now, in all of that information, some of which we can actually ignore, the key word that jumps out is the word given. The minute we see this word, we should think conditional probability. And with conditional probability, a good way to go about those questions is to draw a tree diagram. So we'll set that up. So we're looking at the type of person there, we're looking at whether they read the paper or not, and then our last 2 columns are the default for our outcomes and probabilities. Now, in the question, it mentions 160 people. This we can kind of disregard. It's not actually going to be of any consequence in our calculation. We can change our percentages into decimals if we like, or we can leave them as percentages, or we can write them as fractions. I personally prefer to use decimals, so I'm going to do that. So I'm starting off male or female, and I'm putting in the probabilities of each of those outcomes, and then whether they read the paper or not read the paper. So they're telling me the 75%, I need to work out the rest myself, obviously that's 0.25. And again, then refer to the question for the percentage of females reading the paper, 62.5%. So again, I can use that to fill in these branches here. Then I'll list my outcomes, and then I'll multiply along the branches to get the probabilities. I'm keeping all my decimal places here. And then I'll go back and look at the questions. They want to know the probability the person is female given they read the paper. So what I'm going to do is I'm going to first of all spotlight the people that read the paper. So I've highlighted all the outcomes where people are reading the paper. So it's this gang here that happen to be male as well, and this gang here that happen to be female. And then within that group, I'm going to focus in on the ones that are female. So that is this figure here, 0.28125, and that's going to go on top. And on the bottom, I'm going to sum up my 2 spotlighted areas. And I'll stick that into my calculator and I'll get 15 over 37, or if you prefer to write it as a decimal, you can say 0.4054, or even if you wanted to give it as a percentage, 40.54%. They didn't specify in the question, so whichever of those you prefer is totally fine. Do watch out for that word given. It's always going to be a good old hint that you're looking at conditional probability. B part 1 is actually quite similar to part A of that question. You want to find the probability of B given A, and you'll do that by finding the probability of A intersection B over the probability of A. You can see when you refer back up to part A of the question that that's basically what I've done here in this part of my calculation. I just didn't write in my intersection symbol here because I was reading it directly from the outcomes column. So we have all those values, so we can just plug them straight in. 1/2 over 3/4, and we get 2/3. We do need to be aware of this rule for calculating the probability of B given A. On to part 2, they give us a little bit more information. The probability of A union B equals 11 over 12. and they ask us to investigate if the events A and B are independent. So again, there's a formula that we need to use for this. The rule is that it'll be independent if the probability of A times the probability of B equals the probability of A intersection B. Something to watch out for here. It's easy to make the assumption, since we've found the probability of B given A, that B's probability will automatically be 2/3. We need to be careful with that because that isn't a guarantee. Instead, what we need to do is take the information we're given in all of part B and draw a Venn diagram to establish the value of B. So I've just written down all the information that I know at this stage, and I'm going to draw a quick Venn diagram. So I'll start by filling in the intersection. I know the probability of A is 3/4. That means all of this set is 3/4. I'll take off a half and then I'll fill in the 1/4 in the rest of that set. I know that A union B altogether is 11/12. So if I take these two values from 11/12, it'll leave me with this number here. And just for completeness, I'll fill in A union B complement also, which in this case is 1/12. Now, just watch out that this figure here is not the probability of B. This is B without A. The probability of B is all of this set. So the probability of A is 3/4. We had that from before. The probability of B, in this case, adding these two figures here, makes 2/3. And again, a quick reference to part 1 of the question at this stage. This 2/3 that we've just got here happens to coincide with our solution from part 1. Again, that's not a guarantee, so always draw the Venn diagram to be on the safe side. Now I'll check what I get when I multiply these two figures, and I get a half. Okay, let's have a look back again. So, oh yeah, PA intersection B was a half. So that means my probability of A times probability of B gives me the desired result for independence. So I'll just make a statement about that to conclude. I'm first of all noting that probability A by probability B equals the intersection, and therefore that indicates independent events, and do make sure to put in those concluding lines to get full marks. Okay, so next we have a question about selecting discs from a bag. This question goes back to the essentials of favourable outcomes over possible outcomes. But there's a little bit more to it than that. We've got 12 discs numbered 1 to 12 in a bag. So there's my 1 to 12. And I'm selecting 3 of them. And I want to know what the chances are that 9 will be in the mix. So let's think about what the favourable outcomes would be. What would happen in order for this to work out for me? So I'd pick 3 things out of the bag, and then one of them would be 9. So I'd have a 9 and I'd have 2 other numbers. I definitely want to select the 9. So I wanted to pick this particular number. So from this one number, I want to pick this one number. So thinking of NCR there, I'm going to have 1 choose 1. But that's not all I'm picking from the bag. I still have 11 other numbers aside from that 9 that I want to pick from, and I want 2 of those numbers to also be selected. That means I'm going to also have to account for 11 choose 2. Right, so that's my favourable outcomes. I'm going to get 1 9 and 2 other numbers. And then how many possible outcomes are there? Well, I've got 12 numbers to choose from in total, and I want to pick 3 of them. So I'm going to say 12 choose 3. I can stick this into my calculator all in one go, and I'm going to get an answer of 1/4. That's it, part 1 done. Part 2 of the question, I'm still picking 3 numbers from the bag, and I want to find the chances that the 3 numbers are even. Okay, so let's have a think. So when I think about the favourable outcomes this time, I definitely want to pick all even numbers. So how many are valid to choose from? So I've circled there all my even numbers. There's 6 of them. Any 3 of those will do me. So from the 6 even numbers, I'm choosing 3. And the total possible outcomes is 12 choose 3, still like before. And again, off I go to the calculator, I type it in and get my answer. And this time it's 1/11. In part 3 of this question, I want to see what the chances are that I pick out 3 numbers, and when I multiply them together, I'll get an even number. So I need to think about what could happen with the numbers that I select. I could pick 3 odd numbers. I could pick 2 odd and 1 even. I could pick 1 odd and 2 even, in any order obviously. Or I could pick 3 even numbers. We want to figure out which of these scenarios will give us an even product. And if you're not entirely certain, then just stick some odd numbers into your calculator. Stick in 3 odd numbers, multiply them, what do you get? Stick in 2 odds and an even, what do you get? And so on and so forth. And you'll find that as long as there's an even number in the mix at all, you'll get an even result. There's 2 ways to look at how to calculate the answer for this. You can decide that you're going to look at what's not going to happen or what is going to happen. So we could look at the probability of not getting 3 odd numbers, or we could look at the probability of any one of these occurring, in which case we'd have to add their probabilities because this could happen, or this could happen, or this could happen. Of course, don't forget, plussing is what goes with or. I'm going to go the quicker route. I just don't want this to happen. So what are the chances of picking 3 odd numbers from the bag? Well, this is actually the exact same calculation as we would have had for picking 3 even numbers to the bag, because looking back, there are the same number of odd and even numbers. So I can just say the chances of picking out 3 odd numbers is 1 over 11. I don't want that to happen, so I can subtract that from 1 and I'll get 10 over 11. If I went about it the other way, where I got each of these probabilities and added them together, I would still get 10 over 11 as my final result. And finally, the B part of that question, we've got an archer shooting at a target and we've got the chances that he's going to hit it. Now, there's 2 things can happen here. He can hit it or he can miss it. And so what we're looking at are Bernoulli trials. Don't forget, P is the chances of success. In this case, we're going to take that as being hitting the target. A miss is going to be failure. That'll be Q. We're told in the question the archer is going to fire 9 arrows. That's going to be our N. And he wants to hit the target 5 times. So he wants to succeed 5 times, R is equal to 5. Don't forget your log tables will provide you with the formula for this. And it is N choose R, P to the power of R, Q to the power of N minus R. So we simply fill those values in. So we've got the 5 hits and the 4 misses. Make sure to round as instructed in the question. And we get 0.26 from the calculator. Don't forget that 9 choose 5 at the start is just the NCR button again. Part 2 of this question is just a little bit of a variation on this. We've still got a probability of hitting the target as 4 over 7 and missing as 3 over 7. We want the probability that the 5th hit will occur on the 9th arrow. So we've got some stuff happening with the first 8 arrows, and that 9th arrow at the end, we want that to be a hit. And if we want that to be the 5th hit in particular, that means there must have been 4 hits already. So we're going to do a regular Bernoulli calculation on this part of the statement, and then we're going to multiply it by what's happening with that 9th arrow that hit at the end. So for that part of the calculation then, N is going to be 8 and R is going to be equal to 4. So we're saying 8 choose 4 and then 4 hits and 4 misses, that's our 8 shots. And then at the end, we're going to times by what happens with that 9th arrow. And of course, that particular one we want to be a hit. Again, just watch out that you're following the instructions about the decimal places. In goes the whole lot into the calculator, and your solution is 0.14 to 2 decimal places.